Hello, friends. Welcome to VSET Academy. And we are discussing about embedded system programming. On that, today we are discussing about microcontrollers. And in the last session, we discussed about input or output. And now we're going to discuss about, or the session 2, we're going to discuss about what is controller. All quite simple. I think fairly, if you understand that, you understand. See, try to understand at the very top level. Don't go into the very bottom level, try to do that. That does not work. Okay, please. This is a very important one for us. And what is controller? It's a very surprising thing. What is controller is a very, very nice one. Okay. It's a very tricky one and easy to understand. Not the tough one. Because I've already given you enough clues for that. With that clue, if you try to understand, then you understand. I've told that a microcontroller has a microprocessor and a small ROM to store your program, and there is a RAM for your variable, then there is an output, and there is an input. This is what your microcontroller. And I compare this with your brain. And using brain, you will fit a human being. Am I right? You have a human being. You have a brain. Like that. I make a system, electronic system, with the microcontroller as a brain. Please understand. A brain is an important part of your human being. Like that, microcontroller is an important part of an electronic system. Now let us come to the very important point. There are so many people are there, humans. Now, you take myself, I'm Balaji. I drive my car. I drive my car. Am I right? I clean my house. I cook. Am I right? I do all the activities one by one. And I also write program. I do so many activities. But suddenly I found out that when I'm writing programming alone, that is giving me big money. So programming is giving big money. So what I did, I appoint so many other people to do my work. So many other people do my work. Understand? So this guy is called driver. This guy is called cook. This guy is called maid. Am I right? This guy is called gardener. But I do programming. I don't give the programming to anybody else. I keep programming. So do you understand this? That's what we do. When we start getting money from one activity, we start employing so many employees. Each employee is having a brain. Each employee is having a brain. You also have a brain. So what is the difference between you and them? But you will control all the people. That's the only thing. You are like a manager. You control all the people. Let's say I want to go from Chennai to Bangalore. Previously, I used to drive the car. When I drive a car from Chennai to Bangalore, let's say it takes about 6 hours. It takes about 6 hours. All the 6 hours, I am driving the car. I am driving the car. So I cannot do anything else. My time is wasted. Now, when I have a driver, I tell him that, hey, take me to Bangalore. I spend how much time? Maybe 1 minute. I spend only 1 minute. I told the driver, take me to Bangalore. Enough. I sit in the back seat and open my laptop. I start doing my main activity of programming. My 6 hours is useful now. Now I have to pay the money for driver. Same way, cook. I told my cook in the morning, hey, today morning, you please cook me dosas and eggs. That's fine. And lunch, you cook me biryanis and something. Night dinner, you cook me appam or something. Enough. I tell him what to cook. I spend about only 1 minute. Maid servant, I told him, today you clean all these places. 1 minute. I told this gardener what cleaning has to be done. See that? I spend 4 minutes. My entire work is done. And what is the difference between myself and them? The driver is specialized on driving. The cook is specialized on cooking. The maid servant is specialized on cleaning the house. The gardener is good at cleaning the garden and everything, maintaining the garden. Each one is having all the things, how to drive is stored in his memory. How to cook is stored in his memory. How to clean is stored in his memory. Like that. Here what we have done is this. What we have done was, the beauty here, I have more microcontrollers. Please understand. I have more microcontrollers. All are same. Am I right? But this microcontroller is a one specific task. This microcontroller will talk to only monitor. This guy is called display controller. Like a driver. This guy talks to only keyboard. His memory is programmed to do that activity, like your driver or anybody. This microcontroller is talk to only mouse. This microcontroller talk to only hard disk. You may call this as a mouse controller. This case is called keyboard controller. This case is called hard disk controller. Please understand, they have intelligence. They are like a driver. See, driver has a brain. Driver has a brain. Like that, the display controller is having a microcontroller inside that has a brain, microprocessor, and it has a ROM where it is stored, which you cannot change, which is stored already. So please understand the difference between you and them. You are a manager. You can, each and everybody is having address. This guy could be 6,000, 7,000, 8,000, 9,000. Like your house, if your house driver has a name, your driver is having a name, and driver has a name, Ganesh. Your cook is having a James, and your gardener could be Salim. Your maid servant could be Rajesh. Okay. Understand? Now you give a command to them through your mouth and they listen to your ears. Same way, these guys, your output will go to these people as an input. Same way, their output, when you press a key, will come as an input to them. That's the way you're connected. Understand now? So, These guys are connected the same way. So please try to understand. If you could understand this example, you understand. Previously, when I have a connect the LED, I do it directly. Now I don't do it. I do everything with the help of controller. Controller is having an intelligent and brain. Now, once you tell the controller what to do, let us say you want to draw a circle in the monitor. You tell him draw a circle, he will draw it. How to tell him? That is what his address is there. That is why you write a program, CHAR star X, X is equal to 6000, star X. They will tell you a manual. That manual, they will mention how to write and what to write. So they call these things as controller. As a controller. And every controller is having a brain. Please understand, don't get confused between you control the LED and the switch directly. Now you are controlling via controller. That means that there are so many intelligence people are there. What people did was a very important thing. That is what the trick. They put all this inside the single chip. That is also called microcontroller. They put everything on a single chip. These are called controllers. So please tell, now I'll write it down. Now I write it down. I have a microprocessor. I have a ROM where I store my program. I have a RAM where I store my variables. I have an output. I have an input. This we call GPIO, general purpose input output. Now I have a controller called display controller. I have another controller, controller 2, controller 1, controller 3. So don't get, no, what I'm trying to say is that all these things are same. Now, take a one human being. If you take one human being, he has a brain. Now, if you expand his brain, the brain is having a very important portion called process unit or thinking unit. That is what your microprocessor. Then you have a memory unit, temporal unit. That is memory. That is this RAM and ROM. There are two types of memories. One is long-term and short-term memories. Then you have so many other controllers. This is what all these things. So please try to understand the very purpose of this guy. But I have another human being. He also has a brain. But he is specialized to do only one job. He is specialized to do only one job. He will accept the command and drive the car. He does not know how to manage others. He will do one job. Do you understand this or not? If you have any, if you understand the difference between controller, microcontroller, microprocessor, and memory, input, output. This is a thing. This terminology has to be understood by you very clearly. If you have any doubt on this, let me know now before I proceed further. This is such a nice concept, but it is totally wrongly understood by our people. You'll be very surprised. There's nothing more to explain. We keep on practicing this, that's all. The same concept I'll make you to understand thoroughly. This is what final. There's nothing more to make you, but only one thing is there, I'll tell you. There's only one thing is there. I'll tell you what it is. Then I'll explain to you everything. Now what happened? When I have the controllers inside, the microprocessor address can talk directly. They are to directly. The microprocessor can talk to them directly, all the controllers, if they are inside the single microcontroller. But if the controllers are outside, then the microprocessor cannot talk. So they have connected some wires, and the wires are called, some standards are there. That is called I2C, SPI, UART, CAN. I'll explain them later, very detailed. We're going to discuss about each one, what it is. But before that, we should write a program to understand these things. Then we will discuss. This will be coming the end of the session to be so such a way that you understand everything thoroughly. So there are first to understand one thing. Let us evolve from beginning. Then you see that where you have a doubt. I have only microprocessor. Actually, microprocessor itself was not there first. I had initially was CPU. CPU circuit was long time back, from ENIAC days onwards there. On the CPU circuit, I put it inside the silicon. And make it a single IC. And make it an IC. Oh, that I'll explain to you today. Fine, very good. You asked a very good question. If we combine all of them, what do we call? Very good. That I'll explain to you now. Very good. Yeah. They are very good technique. Okay. Good questions. Keep on asking questions like that. Now I have a silicon. This is called microprocessor. This microprocessor don't have any memory. So it communicates with the outside. The two type of memories. One is called ROM, where your instructions are there. This is non-volatile. It takes from that. Then we have one more thing called RAM. I use it for read and write. Then I have one more thing called output and one more block called input. Understand? We have like this. Now, initial days, people are doing circuit. Then they put the microprocessor separate chip, they all separate ICs. Then they put all of them together in a single IC called microcontroller. So understand now, microprocessor, everything. Then I have a microcontroller does a specific job that is called controller. Please understand the difference between controller and microcontroller. Microcontroller, I can write a program to do any job, whereas controller you cannot change. That program is fixed. It does only one operation, like a driver. He is only driving. Like that, this is called display controller. There's another controller called keyboard controller. This guy can talk to only keyboard. You cannot connect the keyboard controller like you cannot ask a cook to drive like that. Then I have a controller called hard disk controller. Later, what people did was they put all these controllers inside the chip. But don't get confused. Let's say human being has a brain. But brain is having two parts, microprocessor and other one. But you use the brain to connect to the hand, connect to the head, connect to the eyes, connect to the ears, connect to the legs, mouth. Am I right? So these are called devices. Like that. These controllers are connected to device. The display controller is connected to monitor. Keyboard controller is connected to keyboard. And the hard disk controller is connected to hard disk. Am I right? These are called devices. Don't get confused between device, controller, memory, input, output, and microprocessor and CPU. See that. Now what they have done, they put all these things in a single microcontroller. Now I erase this. What people did was they put microprocessor, ROM, RAM, output, input, controllers. They put all of them in a single chip called microcontroller. But this is called controller. You connect the device. Now they have a problem. The problem is they have some new device. There's a new device. Let us assume that there is a motion controller. I move the hand everywhere. That has to be sensed by somebody. Unfortunately, the microcontroller is not having inside. So what they have done, they put the controller outside. So you understand one thing? Motion controller. So there are two types of controller. One is inside the microcontroller, one is outside. To connect to the motion controller, from the microcontroller, there were some wires are there. There are multiple standard. I2C, SPI, UART, and CAN. Even a lot more standards we will discuss for. We will discuss about them. So there are possibilities that controller can be inside, controller can be outside. If controller is not inside, you have to buy it outside and connect it and start using that. This is what all about, man. There's nothing more than that. Whether you talk COM or 8051 or Atmel or Arduino, this is what all about. We're going to discuss about only these things in coming days. Okay. You may not have understand I2C SPI, that we're going to explain now. There are a few wires. Some nerves are there to control them. That means that there is a controller inside your brain. There's a controller outside your brain. How do you connect them? That's the thing. That means that this controller is outside your brain. This is inside your brain. So any doubts here? I think I've started from a CPU circuit to up to the latest controllers. That's it. Where these are all we're going to discuss. ROM, RAM, output, input, what is inside. These are all we are going to discuss in depth in our digital electronics. If you say that how the ROM work, how the RAM work, this one work, input. But how to control these things, we are going to discuss on our embedded system programming class. There I'll explain to you that how to write a program to control all these things, all the controllers. But top level, you should understand the difference between all of them. That is CPU, 2 microprocessor, plus ROM, plus RAM, plus input, plus output. Together called microcontroller, plus microcontroller, plus controllers inside. Then microcontroller plus controller outside. Outside controller, you are connecting to a specific standard. That's it. This is what all about today's embedded system. We are going to discuss these things, how everything is working, everything. That's the only thing. Yeah, both are same, but like a driver and a manager are same, but the difference is driver does only unique job. So hardware wise both are same, but functionality wise different. Microcontroller does all the activity because it has all the controllers. It can do every activity, but controller does only one activity, like a driver. Understand? So microcontroller is also having a brain. Microcontroller is also having a CPU, microprocessor. Microcontroller is also having a input output. There's no difference from the hardware perspective. From the hardware point of view, both are same. But from the functionality, controller does only one activity. Oh, that is different. That is 8051 ROM and Raspberry are different manufacturer. They given a different name. They have a different CPU. They have a different sizes of ROM and everything. I'll explain now that. That's the thing. I'll explain you that now very clear. This you understand very clearly. Then I want you to understand this before I go further. See, I have a name Balaji, man. Okay, you are Karthik, and somebody is Ganesh. They are unique like that. That microprocessor silicon, each one is manufacturing. They have their own instruction, own power. That's the thing. You cannot stand it, man. There's thousands of cars. All the cars are same. They drive on the road. Then what's the difference between Santro and Alto and BMW and Benz? Like that. But don't get confused between ARM 8051 and Raspberry Pi. Raspberry Pi is not microcontroller. Raspberry Pi is the board. 8051 ARM are microcontrollers. ARM is a microprocessor. 8051 is a microcontroller. Even that itself, you talked about three. 8051 ARM and Raspberry Pi. ARM is a microprocessor. 8051 is a microcontroller. Raspberry Pi is a board. Understand? It's like this. I'll explain you now. I'll do it now very clear. So you understand now. Now you'll understand. That is ARM is a microprocessor. Then we connect the microprocessor and memory, everything. Everything. Input, output, input, and controllers. Controller 1, controller 2, controller 3, like that. This is called one single IC called microcontroller. And then what we use the microcontroller on a board. On a board, I put the microcontroller. I put the connectors. I connect them. Such a way that you can use it. You cannot use the microcontroller chip as such, but you can use the board. That's why we need a board. Board is one which is ready to use. That's the thing. Like, for example, you have a product. If you want to ship it, you put it in the box like that. Like that here. Now, let us discuss very top level. There were three things understood by you very clearly. Yeah. Confusing means just go and watch the video once again and you'll be able to get. There were three. One is board. Both of them are IC. Here, IC holder. You put the IC and connectors. Without connectors, you cannot use it. That's called Arduino. Now, the trick here is there were three things there. One is called product. Other one is called system. Other one is called process. Process, system, and product. So the center one is called process. It's a very important. Process is important for every system. The outer one is called system. And the top one is called product. For example, human is a product. Human is a product. It's as such, it can do anything. Am I right? But the human is controlled by a system. Your brain is a system. Understand, your brain is a system. And next one is called your frontal lobe. This is a part of your brain. I told you that the brain, there's a small portion called frontal lobe. That is not full brain. There's only one portion. That is called process. This does everything. This does all your thinking. That is, you are human because you are thinking. You are processing. These are all done by your frontal lobe. In your case, in our case, in the electronics, we have microprocessor as a process. That's why they call name itself microprocessor. That is a key. Next one is called microcontroller. And next one is called system, product. Now, if you take your thing here, it goes like this. I have a process. I have a process. Then you connect with the process multiple controllers. Multiple controllers. Then you connect with them a device. You connect keypad. You connect LED. You connect LCD. You connect temperature sensor. You connect mouse. You connect SD card, storage. Now you understand, this is called process. This is called system. And this is called product. Understand now. But you are writing program here in the process. This will go to everything for even chemical. You have a chemical process. You have any process is there. This will work on any system. But I am explaining about embedded system. Embedded means software. That's it. That is microprocessor and software is called embedded. The other name of embedded is software. Because the name embedded means hidden inside. That is, the software is hidden in the microprocessor. That's a problem. See, you are not able to understand at the top level. That's a problem. The problem here is we try to go from bottom to top. No, we have to go from top to bottom. You need to understand this. If you don't understand the very top level, you do not have to work. You will not have an answer. Tomorrow you will ask me that, why I have to C programming, why not Python? You will never know that if you don't know this. You understand now this. If you have any doubt, you can ask me. This is what exactly I've compared with the human being and your electronic system. You can add any number of controllers, you can add any number of devices. See, what happened, this is what we are using. Suddenly what happened, they start connecting more controllers and more device touch and so many other devices. Okay, SIM card. They start controlling so many devices. Then they start calling it as a SOC. There is a microcontroller and SOC, both are same. No difference between microcontroller and SOC. Both are same. So if you have any doubt, you can ask me now. So please understand, compare with the thing. Your frontal lobe your brain and your hands and everything devices. So your brain gives you the command, and then you are able to control the devices. That's it. So that's the trick. This is a very, 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 if you go back and watch the video, you don't get, I spent so many years to get out, come out at this format. What exactly is a embedded system? This is a very top level picture of embedded system. Okay. If you have any doubt, you can ask me now. This is what all about microcontroller and the controllers. There's no difference between microcontroller and controller. Microcontroller does a generic task. Controller does a specific task. That's it. This is a very top level picture. Try to understand. It's a very top level picture. This is. Now you can control any device. Any device can be controlled. That's why I'm trying to give a very generic picture. I don't want to be attached to only one microcontroller, everything. We'll discuss more. Okay. It's only a start. I'm not ending this. This is only a start. We have another so many months to discuss this. If you understand this, you will understand the computer architecture, mobile phone architecture, everything. This is as simple as that. I'm trying to compare with the only problem is you try to get into very details. Details can be next. First to do the very top level. Then you go to the details. I think I've given enough information. Go and watch the video. Anyhow, I'm recording, I think. I don't, yeah, record is going on. That's fine. I'll post it on the this one, our drive today. Watch the video a few times. You will understand thoroughly. So if you don't understand, so please try now. I'll give you share the board once again. I'll tell you what you have to understand. Anywhere you go, you have to understand these terminologies. What are these terminologies as we understood? First terminology is what is CPU? Then what is microprocessor? Then what is ROM, RAM, input and output? Then what is microcontroller? And what is controller? And what is device? What is controller? Inside chip, inside microcontroller, controller, outside microcontroller. This you connect it through SPI, I2C, UART, and CAN. That's it. This is coming at a memory map. You should understand memory map also. That's it. If you, this is what the top level terminology is. You can do wonders. No, we don't have a microprocessor. Do not have memory at all, please. What they do it here is they put a chip. They put a single chip, IC. They put microprocessor and memory. They have a silicon. Okay, the silicon is, but microprocessor do not have memory. Please don't get confused between microprocessor and the memory. IC. Okay. So I have a space in silicon. So I put this two. Microprocessor have a small memory that is called register. That's it. It's called register. That's all. Nothing more than that. So this terminology is trying to understand. Okay. Okay then. Thanks a lot. If you have any doubts, you can ask me now. Okay. Thank you. We'll meet on Thursday evening on our next session. Thank you. Bye.